talk about how we can identify a MAC address, an IPv4 address, and an IPv6 address. MAC stands for Media Access Control. It is a physical address. It's the address that we typically see assigned to a network interface card, and it is unique. A MAC address consists of 6 groups called hextets, separated by a hyphen, a colon, or a dot. Either one of those ways is valid. MAC addresses are based on the hexadecimal numbering system, so it's a base 16 system, which means it has the typical options we see in the decimal system of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, but it also includes the letters A, B, C, D, E, and F. Those 6 hextets with 8 bits in each hextet equals 64 bits, so a MAC address is a 64-bit address. Looking at the example, you can see that the first hextet has a C1 in it. So in this instance, the C represents 4 bits, the 1 represents another 4 bits, so that's how one hextet can resemble 8 bits of information. In the example, we have our hextets are separated by a hyphen, so this is a valid address that you see. IPv4 stands for Internet Protocol version 4. This is a logical address. Since it's not a hardware address, it can change. It's in 4 groups called octets, and those are separated by a dot or a period on our keyboard. IPv4 addresses are based on the binary numbering system, so computers speak in binary, 0 and 1 for off and on. We often see this converted to a decimal number, so we'll have 8 bits of binary and convert it into a decimal number to be able to display an IPv4 address. So that IPv4 address has 4 octets. Each one of those has 8 bits represented, which makes an IPv4 address a 32-bit address. The example you see at the bottom, 192.168.1.15, is an example of a valid IP address. Internet Protocol version 6 is also a logical address, but the address looks quite a bit different. So we have 8 groups called hextets again that are separated by a colon. This is also based on the hexadecimal numbering system, so we still have our base 16, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F as options. With these addresses, we have 8 hextets, each one with 16 bits represented, which makes IPv6 a 128-bit address. If you look at the example, you can see that the 16 bits comes from each character that you see in this address is represented as 4 bits. So for example, the 2 in 2001 would be 4 bits of information. The first 0 is another 4 bits, the second 0 is another 4 bits, and that final 1 makes it another 4 bits, which means that hextet includes 16 bits, so that is valid. Now, because IPv6 addresses are quite long, especially in comparison to the other addresses that we've talked about in this video, we do simplify those IPv6 addresses sometimes. So there's 2 big rules when it comes to simplifying an IP address. That means that it just looks a whole lot shorter and it's easier to read. So a leading 0 can be eliminated, but never a trailing 0. So in looking at the first example with FE80, the addresses that you see, you can see that, for instance, right here, they have taken out they've simplified these zeros down into one singular 0, and here, for the 0CDE hextet, they've just taken out that 0. So you can take out a leading 0, but you could not take one out at the end of that hextet. So that also makes a shortened version of IPv6. Another thing that can be done is if you have sets of double zeros, if you have sets of zeros, you can use a double colon to shorten them. So in this example, see in this first address we have at the bottom, there are 2 sets of zeros that are right up against each other. So what they've done is they've taken out both those sets of zeros and placed a double colon there. So that can be done, but it can only be done once. This is designed so that if you see a double colon, you can count the number of hextets and see how many are missing. Then you know in that spot there was X number of hextets that had zeros in them.